surfaces in contact. There's friction everywhere in the real world, but it's also different everywhere. The less friction there is between two surfaces
on the first object.
That Isaac Newton was one smooth cat. Now we must move on to our very last topic, and it's my favorite, friction.
Part 6. Friction. Section A. What is friction?
Friction is a phenomenon that impedes motion between two surfaces in contact. There's friction everywhere in the real world, but it's also different everywhere. The less friction there is between two surfaces, the more slippery it is to move across. For example, the lack of friction is what makes it so easy for skis to glide across the snow.
But friction is also what makes it so hard to move furniture across the floor. So let's take a look at this friction thing a little closer.
Section B, kinetic and static friction.
We represent a frictional force with the symbol capital F sub F. Now, F sub F should not be confused with F sub G, which stands for frictional gibberish, which is no help to us at all. Anyway, there are two types of friction that we're going to discuss. These two types are called kinetic friction and static friction.
Kinetic friction occurs when an object slides on a surface and the interaction between the object and the surface results in a force of friction that acts in a direction opposite to the motion.
Say you have a craving for chocolate and you decide to get a big block of it. Here is a free body diagram showing all the forces acting on the block when you push it out of the chocolate store.
The weight of the block is straight down. The acceleration of the block is in the x positive direction because of the force F you are pushing with to get it out of the store. The force of kinetic friction is in the negative x direction, in the opposite direction of where you're pushing.
When two surfaces are pressed against each other, there's also a force that's perpendicular to them. This force is called the normal force, or F sub capital N. So in our example, F sub N is perpendicular to both the floor and the block of chocolate.
Recall that when there's no acceleration in one direction, there's no net force in that direction. Since the block of chocolate has a weight down, there must be a force equal and opposite to it up. And that's the one we call normal force. Otherwise, the block could accelerate down into the floor.
There's kinetic friction whenever an object moves across something. On the other hand, static friction is the force between two stationary surfaces that tries to prevent any motion. Static friction is always greater than kinetic friction for the same two surfaces.
The maximum amount of static friction we can have between any two surfaces before the object we're pushing on begins to move is quantified by the coefficient of friction. The coefficient of friction has no units and is represented by the Greek letter lowercase mu. It looks like a fancy U.
Mu.
When figuring out kinetic friction, the force of friction equals the coefficient of kinetic friction times the normal force. This is written F sub F equals mu sub K for kinetic times F sub N.
And for static friction, the force of friction is less than or equal to the coefficient of static friction times the normal force. Or F sub F is less than or equal to mu sub S for static times F sub N.
Okay, let's do a problem. We'll go back to our chocolate block example. Assuming that our chocolate will not melt in our hands, the mass of the block is 50 kilograms. The coefficient of static friction is 0.45, and the coefficient of kinetic friction is 0.35. What is the minimum force needed to start the block in motion? And what is the minimum force needed to keep it in motion once started?
The first part of the question asks us what is the minimum force needed to get the block going. To get the block going, we have to overcome static friction. So let's figure out what that is.
First, let's set up a free body diagram. The normal force is perpendicular to the floor going up. The weight is down. Force being applied to get the block out of the store is going the positive x direction, and the force of friction is going in the negative x direction.
Second, we have to figure out the normal force. The normal force is perpendicular to the floor, and we've already learned about the force that is equal and opposite the normal force. And that force is weight, mass times gravity. The weight equals mass, 50 kilograms, times gravity, negative 9.8 meters per second squared, which is negative 490 newtons. So the normal force equals the opposite of that, or 490 newtons.
Now we need to get the force of static friction before the block starts to move. Remember, the force of static friction equals the coefficient of static friction, mu sub s, times the normal force, F sub n. Plugging into the formula and chugging, we get that F sub F equals the static coefficient, 0.45, times the normal force, 490 newtons, which is 221 newtons.
So in order for the block to move, it would take a force greater than 221 newtons.
Now let's tackle the second part of the question. What is the minimum amount of force needed to sustain motion once the block is moving?
Well, we find this by figuring out the force of kinetic friction. Even though it takes a force greater than 221 newtons to get that chocolate block going, we probably won't need that amount to sustain motion. Why? Well, because static friction is always greater than kinetic friction. So once we get that hunk of chocolate going, there's less of a force acting against us.
So the force of kinetic friction is the coefficient of kinetic friction, mu sub k, times the normal force, F sub n. That's 0.35 times 490 newtons, which is 172 newtons. Therefore, it takes a force of at least 172 newtons to sustain that chocolate block motion. If you push harder than that, the block will accelerate.
Friction is a phenomenon that impedes motion between two surfaces in contact. There's kinetic friction when an object slides on a surface, and the interaction between the object and the surface results in a force of friction that acts in a direction opposite to that of the motion. Static friction is the force between two stationary surfaces that inhibits motion.
The normal force is the force perpendicular to the touching surfaces and is opposite in direction to the object's weight when the surface is horizontal. The coefficient of friction, mu, is a measure of the amount of interaction between two surfaces that results in a frictional force when an attempt is made to move an object. Kinetic friction equals the coefficient of friction times the normal force, or F sub F equals mu sub k times F sub n. And static friction also equals the coefficient of friction times the normal force. F sub F equals mu sub s times F sub n.
This is the juice, baby, from WPHY, home of the gravity-packed World of Physics Part 1, and also the hub of the strong songs. So good night, my massive and forceful people. Sleep well.
I learned about vectors.
I learned about kinematics. I learned about momentum and force.
I learned about friction. Thanks for watching the Gravity-Packed World of Physics, Part 1. We've covered a lot.
So don't be afraid to rewind the tape if you need to go over anything. Be kind, rewind. Now! Now!
And check out the Gravity-Packed World of Physics, Part 2.
Where you'll learn about work, energy, waves, and other groovy stuff.
And of course, you can always call us at 1-800-238-9669 if you have any questions or comments.
I'll catch you on the rebound over on the sunny side of good night.
Roll it. Tony, can you roll one?
First object. That was a different one.
Newton. Awesome. Just like Newton's first law says it will. Oh my God, no!
He's got no head. That was messy and sad, but so is Sid.
We're still in the ideal world.
We know it's A and B, but before we can get down and dirty with these equations, I
feel like Max Headroom. Because in the real life,
Seriously, the juice is not happy, okay? The juice is not happy.
Are you guys like hurting for bloopers or something?
Can I please have some juice?
but before we
Notice, if we add vectors, A's component represented by the Greek little
Bye, folks. Thanks for coming.